Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this word problem using derivatives. So as per the problem, a professional basketball team plays in an arena that holds 20,000 spectators. Average attendance at each game has been 14,000. The average ticket price is $75, and market research shows that for each $5 reduction in the ticket price, attendance increases by 800. Find the price that will maximize revenue. So we are given that the average attendance in a basketball game is 14,000 and the average ticket price is $75. Now we have to find by how much should the ticket price $75 be changed to maximize revenue. So for this problem, we'll have to use a variable for the number of $5 reductions in the ticket price. So let X represent the number of $5 reduction in ticket price. So X can be 1, 2, 3 or any whole number. Now we have to find the new ticket price. So the expression for new price will be, since it's a reduction, so it will be 75 minus 5x, because the ticket price is being reduced by $5 x number of times. And now the new attendance or new number of tickets sold is equal to 14,000, which is the average attendance, plus 800x, because the attendance increases by 800 for every $5 reduction. Now we can write the revenue function. So R represents revenue. So revenue will be equal to the new price, which is 75 minus 5x times 14,000 plus 800x. So this is the revenue function in terms of x. Now we can distribute the terms in the parentheses using the FOIL method. So we'll multiply 75 by 14,000, then 75 by 800x, then negative 5x by 14,000, and then negative 5x by 800x. So we get R equals, so first we do 75 times 14,000, which is equal to 1,015,000. Then we do 75 times 800, which is equal to 60,000, and then x. Then we do negative 5x times 14,000, which is equal to negative 70,000x. And then we do negative 5x times 800x, which is equal to negative 4,000x squared. Now we can rearrange the terms in this revenue equation. So we can start with the x squared term, so negative 4,000x squared, and we can combine the x terms, so we get negative 10,000x, and then plus 1,050,000. Now we can find the domain for this revenue function. So we are given that the arena can hold 20,000 spectators, so that's the maximum capacity. So the maximum number of tickets that can be sold for a game should be equal to 20,000. So 14,000 plus 800x should be less than or equal to 20,000 because that's the arena capacity. Now we have to solve for x. So first step is to subtract 14,000 from both sides. So 14,000 on the left side will cancel each other out and we get 800x is less than or equal to 6,000. Now we can isolate x by dividing both sides by 800. So the 800 on the left side will cancel each other out and we get x is less than or equal to, so we do 6,000 divided by 800, which is equal to 7.5. So x should be less than or equal to 7.5. Now also the new number of tickets sold should be greater than 0 because number of tickets sold cannot be negative and we cannot sell 0 tickets because if we sell 0 tickets the revenue will be 0. So to find the lower limit for x we get so 14,000 plus 800x, that's the new number of tickets sold, should be greater than 0. And now we can, sorry, it's 800 x. Now we can solve for x. So we should subtract 14,000 from both sides. The 14,000 on the left side will cancel each other out and we get 800x is greater than negative 14,000. And now we can divide both sides by 800. And the 800 on the left side will cancel each other out and we get x is greater than, so 14,000 divided by, so I got negative 17.5. That means the domain for this revenue function can be written as x is greater than negative 17, sorry, I'll write it again. So I'll write it in a different color. It's easy to understand. So negative, so x is greater than negative 17.5 and less than or equal to 7.5. So any x value that we find should lie in this interval. Now we have to find the price that will maximize revenue. That means we have to find the x value at which this revenue function forms peaks because peaks represent maximum revenue. And at those peak points, the slope of the tangent will be equal to 0 because the tangent will be horizontal. And if the tangent is the slope of the tangent is equal to 0, that means the derivative is equal to 0. So we'll find the derivative of this r function and then set it equal to 0 and solve for x. So we'll start with r prime equals, now in the first term the negative 4,000 is the coefficient, so it will stay the same, and as per the power rule the derivative of x square is 2x. Now in the second term negative 10,000 is the coefficient, so it will stay the same and the derivative of x is 1, and 1,050,000 is a constant, so its derivative is equal to 0. Now we can set the derivative equal to 0, so 0 equals, so negative 4,000 times 2 is negative 8,000 x and then minus 10,000. Now we have to solve for x, so first we can add 8,000x to both sides. So 8,000x on the right side will cancel each other out and we get 8,000x equals negative 10,000. And now we can divide both sides by 8,000. So 8,000 on the left side will cancel each other out, and we get x equals negative 10,000 divided by 8,000, which is equal to negative 1.25. Now this x value lies in the domain that we found for the revenue function. That means this is a valid x value. Now we'll find the revenue at the three x values at negative 17.5, negative 1.25 and 7.5 and see where the revenue is maximized. And for that we'll use the revenue function. So we'll start at negative 17.5, the lower end of the domain. So revenue at negative 17.5. So we'll sub in x as negative 17.5. So negative 4,000 times negative 17.5 square, and then negative 10,000 times negative 17.5, and then plus 1,050,000. Now we can evaluate these terms. So revenue at x equals negative 17.5 equals, so first we do negative 4,000 times negative 17.5 square. So I got negative 1,225,000, and now plus, so now we do the 10,000 times, or negative 10,000 times negative 17.5, and that will become positive. So 175,000. And then plus 1,050,000. Now we can combine these three terms. So negative 1,225,000, and then plus 175,000, and then plus 1,050,000. So I got 0. So the revenue at negative 17.5 is equal to 0. Now we'll use x equals negative 1.25. So I get negative 4,000. So we'll sub in x as negative 1.25 square, then negative 10,000 times negative 1.25, and then plus 1,050,000. And now we can evaluate these terms. So negative 4,000 times negative 1.25 square. So I got negative 6,250, and then negative 10,000 times negative 1.25. So I got 12,500, and then plus 1,050,000. Now we can combine these terms. So r at negative 1.25 equals, so negative 6,250 plus 12,500 plus 1,050,000. So I got 1,056,250, and that's the revenue. So the unit is dollars. Now we'll find the revenue at x equals 7.5. So we'll sub in x as 7.5. So negative 4,000 times 7.5 square, then minus 10,000 times 7.5 plus 1,050,000. Now we can evaluate the terms. So revenue at x equals 7.5. So first we do negative 4,000 times 7.5 square, which is negative 225,000. And then negative 10,000 times 7.5 is negative 75,000. And then plus 1,050,000. Now we can combine these numbers. So I got minus, so I got 750,000 and the unit is dollars. So we can see we obtained the maximum revenue at x equals negative 1.25. So that's the x value we are looking for. Now we have to find the price that will maximize revenue. So for that we'll use the price expression. So we found that the new price will be equal to 75 minus 5x. So it will be negative 5 times negative 1.25. So we get 75 minus 5 times negative 1.25. So I got 81.25 and the unit is dollars. That means the company or the team should increase the price, not reduce it, to maximize revenue. And the price that maximizes revenue is $81.25. So these are the steps you have to keep in mind to solve this problem. So in this case, even though the research talks about reduction in ticket price, the result that we got is that the price should be increased to maximize revenue. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.